Hi everyone and welcome back to the channel. In the previous episode we implemented sprint and jump mechanics for our Sly Cooper character. Today I want to introduce you to state machine and show you how to implement one in our project. A state machine is an approach that allows us to manage a character behavior in a clean and organized way. Think of it like this. In a game, your character can be in a different states: idle, running or jumping. Each of these states has its own logic, different animations, controls and available actions. Instead of writing one big messy script that checks everything at once, a state machine lets us split behavior into separate smaller pieces. This makes the code easier to read, maintain and expand. So how it works? Here's the basic idea. We have a central component, the state machine, which keeps track of the current state of the character. Each state is its own script defining what happens when we enter that state, what happens while we are in that state, and what happens when we leave it. For example, when the character starts jumping, the machine switches from the running state to the jump state, and all control logic changes automatically. This system is very flexible. If you want to add new actions later, like climbing, we just create a new state without rewriting the existing code. Now that we understand the concept, let's implement it step by step. In our player scene, we add a new node called state machine. Inside it, we add 4 child nodes, one for each state: idle, walk, run, jump. Once we have the entire node structure, let's add the first script, which we will call state. This will be the base class for all states. It defines all the functions that state machine will call, but without implementing the actual logic. That logic will go into individual scripts that inherit from state. At the beginning of the script, we give our class the name state. Next, define all the required methods that our state will share. When the base state script is ready, let's create a new script called player state, which inherits from state. This will extend the base functionality to include player-specific logic. In the script, we declare a player variable of type player. It's a reference to the player object. To make this script work, we also need to add class name player to the player script. Now let's add a ready method. In this method, we wait for the owner to fully initialize and assign it to the player variable. Owner is a built-in variable in Godot that points to the object to which the script is attached. Using await owner ready ensures that before we try to obtain a reference to the player, it already exists and is correctly initialized. Next, we add a safety check. If the owner isn't a player object, we throw an error, player not found. Now we create the main script, state machine, which controls the current state. On the beginning, we define a signal that will be emitted however the state changes. Next, we create an export variable for the initial state and an onReady variable for the current state. Now, if we attach the script to the main state machine node, we will be able to attach a node with the selected state. We assign the idle node to it, which is to be the default state of the player. In the ready method, we wait for the player to initialize. Next, we iterate over all children of the state machine and assign them a reference to it. This allows each state to communicate with the machine. Next, we call the enter method of the current state. Now we also add a handle input, process and physics process methods that forward events to the current state. Now let's add the transition function, which is the main method for changing the state. On the beginning, we check if a node with the new state name exists. Next, we call exit function on the current state and we set a new state as active. Next, we call enter function to the new state. Finally, we send a transition signal with the name of the new state. However, when we try to run our game, we get an error. This is because we need to prepare a separate script for each node with a state that will inherit from player state. Now, after creating and assigning a script for each player state, we can run our project. Okay, in this episode we build the foundation of the state machine for our player. In the next episode we'll refactor our current player code and move the appropriate logic elements to the appropriate states. If you enjoyed this episode, don't forget to leave a like, comment and subscribe. It's really helped me to stay motivated to keep making more content. Thanks for watching and see you in the next one.